So jit.gin does the CPU processing of matrices. And that is computationally intensive, right? And that same code could be moved somewhere else. The exact same code could be moved somewhere else and could run on the GPU, because we can also compile it down to what is basically a shader. So that's what I want to talk about today. And we'll, in the process of that, I'll try to clear up some of the crazy gen stuff that I didn't do so well last class on. I didn't even post the video because I said, you know, I don't know if that's even helpful. There's so much not clarity. Yes, the GIF. All right, let me do it this way. Okay, so I'll share my screen. All right, and let me get a new patcher. All right, so I did send you guys out an email based on Jarrett's suggestion of a playlist by the Amazing Max tutorials, where you go from jit.gin 0 to hero in something like 9 episodes. And I think it's really well done. And so if you really want to get very familiar with it, you can check out that playlist. I recommend. But something he did is something I'm going to capitalize on here and go a little further with. And that is to transform. We're going to transform a video. So up to this point, right, we've been using jit.gin to generate vertices primarily. So, and let me clarify that terminology. So I say vertices, that means points in a shape, right? Something we might send to a mesh. Or it means points in space, somewhere we might position objects. Or whatever. We make those vertices. And that's different than manipulating pixels, which is what we see in a video, right? So video itself really doesn't have vertices. It just has little points of color that make up the video. And jit.gin can deal with either of those because they're both a matrix, right? A matrix of pixels, a matrix of vertices. So what I focused on primarily up to this point is the generation of vertices. And we see that looking inside the gin, our standard thing to do is to just put I can't see, is to just put an S norm in here, assigned normalization, which gives us numbers between -1 and +1. Now, where does it give us those numbers is the confusing part of this. So jit.matrix 3 planes now, because I'm talking about X, Y, and Z in dimensional speak. Float 32 is almost the best way to work in all cases. And let's make it a 4x4 matrix. And so I'm just going to continuously output the matrix so that I don't have to continually hit a bang button. And our cell block here, and I might as well go ahead and change this because I always do. That's something I'd like to see changed, is that default is bad. All right, and look at all the planes. And there we see that across two of the planes, we have -1 to +1. All right, and how does it go? Right, so across the X dimension is going to correspond with the 0th plane here. So the plane that happens to correspond with X in our scenario here, because we're dealing with X, Y, Z. Now this could be something else, right? This could be color or whatever, scale. So it just happens that this four across on the horizontal, how we have our structure of the Excel sheet, so how many columns do we have, 4, is going to be associated with the first plane. So across the horizontal, we get -1, negative 0.33, 0.33, and 1. Right? The second dimension, y, happens to correspond with the second plane. And so the second plane seen here will, across the vertical axis now, go -1, negative 0.33, 0.33, and 1. And then since we don't have anything in the z dimension of our structure, it will not inform the third plane here. So we just get zeros. Right? So to beat this horse dead a little bit, because it's really important, here I've got one dimension on the y, and so we see that across the horizontal, the 4 columns, which are associated with the first plane, we will get -1, negative 0.33, 0.33, and 1, and then I did put one dimension, one row, on the y, and so we get -1 trying to go to 1, but it never can. Right, on the vertical axis on the second plane, because the second one is associated with this second dimension. Any questions about that? Because that's really important.
Can you please show the jit.gn code, please?
Sine normal out. So this sine normal contains what, right? It's just outputting 3 planes, and there's nothing to inform the third plane. Right? So right now I just have these 2 dimensions. If I were to put in a third plane, I guess the question is, and we won't be able to see it in the cell block, so it's going to complain. And we can try to see it here. Maybe I should turn this off now.
Is this like a tesseract now?
No. Not yet. That would be 4 dimensions.
But I mean, that fact that it's the 3 XYZ and then it's another dimension of XYZ. I don't know.
No. So I'm glad you said that, because we have these 3 planes, right? And these 3 planes are not X, Y, and Z necessarily, right? I haven't done anything to make them X, Y, and Z.
They're just 3 separate streams of information, right?
Right. It's like 3 channels, or there's 3 numbers in a cell,
or
right?
Rows and columns, if you want to like retain the whole spreadsheet idea.
Right. So the spreadsheet idea kind of goes out the window because we've got rows, columns, and what's, like, I don't know, 3-dimensional Excel sheet. Anyway, so if we have this, the theory is, right, that we should get -1 to 1 on the x, and then -1 on the y, and I think -1 on the z, because I did supply a dimension for that here. So there we have it. I don't know if you can see it, but it says -1, -1, -1 across the x, negative 0.33, -1, -1. So, and that's different than if I don't supply a dimension here. And now I'm going to see that we have a 0 in the z slot. If I don't supply a dimension here, then we're going to have it totally thwarted me. What did it do? It just freaked out. So I don't like that at all. I didn't do what I expected at all. That's what I expect. All right, good. So this S norm thing, that's the way it puts numbers across things. If I change this to norm again, then it's just the numbers that go across this are different. So now across the horizontal axis, and we can change back to jit.cellblock. The numbers that go across this now on the horizontal axis, because that's what this corresponds to, is the columns 0, 0.3, 0.67, and 1. And that's because it's norm and not S norm. Now, what would happen if I put cell here? What numbers would I get in this spreadsheet across the x-axis?
Zeros? Because it's not being normalized?
No, it would be it'd be 0 to 3 and one dimension. It'd be the dimensions essentially.
Well, it'd be kind of, right? It's not the dimensions because the dimensions are 4 by 1.
Yeah, so wouldn't it be? It would be 4, 4, 0, 4, 1, 4. No, wait. Yeah, it would be something like that, right? It would be coordinates of the dimensions. So it would be, yeah, right.
It would be which column and which row,
Yep.
right? So here we would have column 0, row 0, column 1, row 0, column 2, row 0, and column 3, row 0.
So it's 0 to 3, right? And then
That's
the
right.
one dimension of it, and it's the dimensions, right?
Well, it's bound by the dimensions. So, right, if the dimension were higher, if this were 40, then we would have 0 to 39.
But it's not reflective of the value stored at the dimensions. It's returning the dimensions themselves.
I would say it's returning the index of the column, or it's returning the column number and the row number. Maybe it's this easy way to do it. Let's look at it. So we see 0, 1, 2, 3. 0 with column, first column, second column, third column. And the row, of course, is always the 0 with row because we only have one of them. If we have 2, what do we expect to be in the second plane now going down the vertical axis? 0, and then what will this next number be?
1.
It'd be,
1.
yeah, it'd continue to count.
Right, so now we have 0 and 1, and if I do 4 going down, I have 0, 1, 2, 3. And across here, I've got 0, 1, 2, 3. So it's the same as
Having
normalizing.
no gen at all.
Well, no, because if I had no gen at all, what would be the output of this matrix?
All zeros.
All zeros, right? So that's the information contained within the cells. So that's kind of what we have to separate out, is like the information contained within the cells and the structure of the cells itself. So here we're just kind of looking at a structural element. Like there are just these many columns and rows. It doesn't even matter what's in the matrix right now. It's like these are just what's there. And if I had a z, right, then what it would do is it would say, well, for every dimension of z, I will give you the index number going back into the screen, right? And, okay, and then finally, the dim thing is just going to put the same thing into all of the cells because the dimensions of the matrix don't change per cell. It's the dimensions of the matrix. So 4 by 4, if you want that information. All right, so ask me a couple questions about this. We've got S norm, and we got to know these things. S norm, norm.
I was trying to assign a cycle object, but at different phases for each index,
Yeah.
right? So, and then I was going to pass a param as like a y offset because I wanted a sweeping wave. But what was happening is all of the dots that I was creating with the gen and the matrix were just moving at the same speed. And so I didn't know how to offset them based on what their index is.
Mm-hmm.
And phase-wise, though, because I can't just offset, because what it's doing is returning an amplitude, but I need to account for the phase of that cycle object so I can get a different, I probably can't even use the cycle object. But you see what I'm saying, where they're all going to be at different phase increments of a sine wave. So they're all going in a sine function up and down, but they're offset slightly. So it looks like a wave moving through a line of points.
Okay.
So I guess more so would be like, scaling a sine function so each cell has a slightly different phase. To like, so in this case, it would, over the 16 cells, those would all be 16 phase increments of a sine wave, and they'd all be kind of on their own sine function.
They'd be on their own sine function.
Is what I was thinking. Well, actually, I don't know. Take that part out. I just want them to move like a wave.
Mm-hmm.
A line of 10 points, let's say.
Okay, let's get to that. But before we do, let's just make sure everybody knows what these 4 things mean, because this is pretty important.
Well, it depends on context. I take that back, because normal is what it's called, the one I was thinking of.
Like normalize.
So S norm is taking whatever the dimensions are and plotting them between -1 and 1.
Plotting the planes associated with those dimensions.
Yeah.
Right.
And then norm is 0 to 1.
Yep. Cell is you
I'll
know,
let someone else talk.
The index
Oh.
of the cells
right. So
rather
kind of
than
the
the contents.
column row number, and then of course when we start talking about more dimensions than 2, it's harder to talk about it that way. And then dimensions are just the dimensions. So that's the basics, right? You know, what do we do with something like this is the harder part, I suppose. And so what Ryan is saying, and I think I'm going to try to get back to that because I know what you're saying, but I want to get back to it.
I wish I could think of a simpler way. I just want to address them individually.
Well, it does address each cell individually. So, so if I have this norm, right, which is going between 0 and 1 on, let's just say, just across the x, right? So I have to plug it actually in to make it do anything. So now we've got 0, 0.3, 0.67, and 1, right? If I take the, if I multiply this by 2 pi, so that now instead of going from 0 to 1, it goes from 0 to 2 pi, then we get different numbers, right? So now it goes all the way to 6.28. If I take the sine of that, then I have numbers that go up and down based on a sine wave, right? So this is how I would create a curved line. To show the curved line, I could do jit.gl.mesh, a space I haven't made yet, at draw mode, line strip. I think that's all I need for this. And then jit.world, a space. And hook this into here. And there's my line. It's a little bit small, I suppose. Looks like. It doesn't look like it's really showing me what I asked it to, does it? So let me see here.
Don't you need to bang it again? I guess that Q Metro is banging it constantly, so never mind.
So it's banging this thing here. This is what's coming out. Oh, I see. So we're just defining the x here. So to define a curve, right, we would need 2 dimensions. So really I should be defining the y based on this. So now instead of, so let's swizz out the x here. And what I want this to be is actually these numbers that we had before, right? They're supposed to be the y values. And then the x values can just go from 0 to 1, or even they could go -1 to +1. So let's use S norm. We'll swizz out the x again here. And so now when we pack up a vector, we'll say that x goes from -1 to +1. And y is going to follow this sine wave trajectory, up and down. And we'll just leave x at z at 0. And so there's a really crappy sine wave. Why is it so not curvy? Because we just don't have enough points here. So we can easily change the dimensions of this, and then it looks like a sine wave. If I wanted to change, yes.
I'm confused. So you swizzed out the x on both S norm and norm.
Yes.
Aren't you getting two? I'm a little confused on why you wouldn't put one of those as y.
Well, because my y right here is only 1, remember? So I'm just getting, I'm not getting anything going down the y, the vertical, right? There's nothing filling plane 2. All plane 2 is just 0 out of this norm.
So you're just using one number from the matrix to make this sine wave.
Right, because it's all I've really got. I've only got -1 to 1 here and 0 to 1 here on the x.
Well, it's because we have like multi-dimensional storage of multi-dimensional coordinates is where it gets confusing for me. Because which y are we referring to? The resulting y that is going to determine the placement of the point, or the y in the column row scenario?
Right, maybe it's even clearer to just look at it like this. Like, take the 0th thing out of here. right?
Yes, I always forget we can do this.
That is not necessarily x. It's just the 0th plane, right? And that's the only one I have information on. The second one just stays static, right? So if I were to try to get pi of this, it's not gonna look like anything, because it's like, well, pi of 0 is, I'm sorry, 2 pi times 0 is still 0. Sine of 0 is 0. So there it is, 0.
So the way that I'm kind of thinking about this is you're just bending the line, right, with gen.
Well, I'm defining the x that goes left to right from -1 to +1. And here I'm taking 0 to 1 and multiplying it by 2 pi. So there's actually 40 steps of 0 to 1. Multiply it by 2 pi, it goes 0 to 6.28, takes the sign, now it goes -1 to +1. And that's informing my y values. So y all along here, all 40 points follow these amplitudes.
I guess what's confusing me is, like, you're looking at the cell block and there's nothing. I mean, it's just 0 in the y. So that's what's confusing me. It's like,
Well, not anymore, right? Right here is 0, 0.16. Why is that changed? We said that if we normalize or we S-norm across this, we're not going to get anything. There's only one row. How could it go down any more rows? There's only one, and it doesn't. That's why I have to take out, just to rely on x for everything here, because there's actually not any information in y that's useful. It's zeros. So
right.
so what's coming in is a matrix, right? And then this S norm and norm inform x and y. So here, if I swizzed out y, it would actually be -1, right? All the time, because there's only one row. And that's not useful to me either. It's just a constant number. I would rather have numbers that move from 0 to 1, right?
Yeah.
Or I could be more inefficient and be like, well, I'm going to get a 40 by 40 matrix here, and now I will swizz out the y here, because it just makes more sense to me, right? Well, and that happened.
A lot of lines.
That's a lot of lines. So, oh, right, because now we're doing something really strange. So I shouldn't have changed that, because I was trying to draw really a two-dimensional line, or line on one dimension, really. Yeah. So to me, this makes sense, because we just have to remember this is really just the first plane, which again is being informed by this number, right? It's like this number corresponds with the 0th plane, and so across the columns we get 0 to 1 or -1 to 1. And we can make shapes with that. To continue to answer Ryan's question, to change the phase of this, we would just plus some number. And typically this is a number that you might want to move. So we use our param phase. And that allows us to pass in some number to this gen thing. So here we say m phase $1. And now we can do this, which is interesting. Not what I expected.
I think you didn't plug it in the.
I didn't put it in the right place. I was supposed to put this in above here. So let me. How do I do this? I would shift. Nope. Yeah. So before you get to the sign, we have to change the phase.
And that can go above 2 pi. It'll just wrap around with sign, right? I forget.
It'll wrap around. That's right. And so now we can make it look like it's moving.
That's not how I totally did not think of doing it this way. This is crazy. I thought I'd have to use pull the car in some way and then like assign the amp and then skew the, I don't know. I guess I don't understand pull the car that well. I don't understand why they're called imaginary numbers.
Well, that's a different topic. That's a long conversation. So, but how do we change the frequency of this sine wave? Right now it's 1 period because it goes from 0 to 2 pi.
You could put a multiple before the 2 pi, right?
That's right. So we could say multiply by some frequency. So I'll just default it to 1 right now, so it won't do anything. And so now we multiply these numbers, which again are just 0 to 1. So now they're bigger than 0 to 1. And I don't think it would really matter if we put this multiply before or after the 2 pi. And then we could change the frequency here.
But so if I
You'll have to put frequency in that multiplication box in the gen.
Thank you. And then we say, well, let's make 2 in the space, or 3 in the space, or 4.
could we drive this from a cycle object in phase? Does cycle output phase?
Well, cycle outputs -1 to +1, right?
Mm-hmm.
So it depends on what we want our phase to be. So we can
You
do
like
cycle.
scale out of the cycle object, right?
Sure. So let's say cycle, and we'll just give it some frequency, and the numbers coming out can be scaled. So what was going from -1 to +1 will go from, what makes sense for phase? 0 to 2 pi.
Don't those have to be floats?
Not in the signal world. There is no integer
That's
in the
right.
signal
Yeah.
world. Okay, so then we've got this, and we want this to go there, but it won't, right? We need the snapshot. And I'm going to have to get back on track here in a second to show you what I wanted to show you. And that's going to go here, and then we can drive this with this metro, for instance, or maybe we want to do it with this thing here. And now we're moving it, and we can change. And I don't really like that because it goes back and forth. I guess I could do that. It doesn't please me quite as much as I want it to. So, yeah. So back and forth. Okay, so there's that.
Thank you. I can't believe that, though. It's totally different than what I guessed.
Yeah, I mean, basically you just have to define a curve this way. And this is an audio concept, actually. So if you look at Miller Puckett's electronic music book, he goes through this in like the first chapter or something like that. Okay, but let's not do this anymore. Let's not do that. And what I want to do now is I want to look at what if I bring in a video to this instead. So I'm not going to look at a 3D space anymore. I'm going to look at just a P window. So jit.p window. And because now we're not in the GL space, jit.gen is going to take in, remember that jit.gen is not a GL object. So color in jit.gen is ARGB. And what we're going to do is we're going to take in a video, and this video I'm going to scale down to 320 by 240 for performance issues, which is not what I want to do, which is going to lead to the thing we talk about hopefully here in just a second. So here's our video of chickens, and we need to make this 4 planes. I don't need to do that. 4 planes, loop the chickens, go into the gen, and then we'll just put in to out for right now. Now notice that I changed this chickens to a float 32. So what was going between 0 and 255 will now go between 0 and 1. It won't have any visible effect. It'll still look like the chickens. But it does make it easier for me to think about it here, right? Right, so we have 2 dimensions here. What would happen if I did like norm here? What would happen? And we're dealing with
It would scale 320 and 240 between 0 and 1
That's correct, and that would associate with which planes?
with ARGB, or well, AR.
Just AR,
Essentially.
right? So what we would expect here, we would expect it to go red. That would make sense, and there it is, right? So from on the red, which is our y-axis now, right? So if we looked at the cell block, we would see that across A, which we're not seeing any effect of, we have 0 to 1 over 320 cells, and over R, the second plane, we have 0 to 1 over 240. So that's what we see here. How would I make it so that it does it across the red and the green?
You would have to swizz out the 0 or
Okay, so let's say swizz 0, which there's two ways to say that, or I could have said swizz A. Well, let's say swizz 0.
so it
Yeah,
does.
I don't think even need to. I think you can just make a vector out of it and fill it all from norm. I guess I don't know what'll happen then when it gets to the next dimension.
Yeah, how do I do this? Because this is already a vector. This is 4 values, right? These 4 planes. All right, so we said swizz out the 0, which is the A. Swizz out the 1, which is the R. And now we need the vector, right? And we'll say 1 for the alpha. And now we'll say, where do we want these to go? So do we want 1 to go, 0 to go to 0? A to go to A? No. We want A to be the R now. And we want R to be the G. And so now we'll get red and green.
Well, but it's weird because it's not 320 by 320 though, right? So they're normalizing differently.
Well, yeah.
Right? Okay, I don't know. That's what
it doesn't matter. So what would happen if I wanted to instead see red and blue? What would I need to do?
Connect to the
Just
rightmost
move it
of
over,
the
right?
yeah.
Yeah, so here, you know, because these are just numbers, right? I say, well, I want to see blue, not green, right? So then I see blue, not green. 0 to 1. What would happen if I made this S norm?
It would mirror itself. Or this would, what we see here is going to be in the top right quadrant, and then it's going to have inversions of that in the other 3 quadrants.
So it's going to make negative numbers, right? How do we represent black in a P window?
Yeah, so it's just gonna be.
Oh shit!
Black,
Yeah, it
black,
won't.
right?
Yeah, so it's just going to have like a lot of black, and eventually, about halfway through, we're going to get the colors, because you can't represent negative numbers; they're just black, right? So this is the same as basically clipping to 0. So it makes more sense to use norm here, right?
If you wanted to do what Ryan was talking about, you would just use absolute, right? ABS.
Yeah, I think that.
Well, what would that do with S norm? You mean?
Yeah.
Okay, so right. So with S norm, we could say we'll go from -1 to 1, and we really just go from 1 to 0 and then 0 to 1, right? If we did the absolute value of that. So let's do it. And what's nice about this is that, you know, I don't have to worry if I'm working with a vector or not. Absolute will work on a vector or anything else. So now we have the mirror.
I have a question.
Yes.
So, you know, you're playing a movie in there. It's not changing at all.
Right. So what is this S norm? It's like, it's not based on the contents of this matrix. It's only based on the structure of the matrix. Right? If I want to get the movie, then I have to get N1, right? Because that's what that is. Right? And then I could say, all right, I'm not interested in any of this stuff here. Instead, I'm going to, let's say that we want to just swap the planes. Let's say I want to make, I want to do what's green is going to be red, what's red is going to be green, and the alpha is going to be blue. No, I don't want to do that. What's red is red and blue, and I don't know. I want to swap the planes around. So let's take out all the planes, and we'll just swap them how we want. So 0, 1, 2, and 3, which could be named Swizz ARGB, and it would still work. So we take in the movie, and we say, all right, I'm going to get all of these different parts of the movie. And I'm going to say, all right, so what was the alpha can just stay the alpha. But the red is going to be the blue, the green is going to be the red, and the blue is going to be the green, right? And so then I change the colors of my movie. I colorize it in a different way.
Do most like random video files that we just have on our computer, do they have alpha values stored in them?
Probably. It depends on which format it is. All right, so there we go. That's kind of interesting, right? And I do use this at some point. I just like quick way to swap planes. It's easy enough. But I want to see something more interesting. And like I said, based on the Amazing Max tutorials, he does this thing where he says, well, okay, so let's say that we've got S norm, which are values from -1 to 1, right? And if we look at this, it's going to look like on the red. And we already discussed why, right? So now we're clipping off until we get halfway, and then we see, because if we were to look at this, we would see there's really only two things. There's Swizz A and Swizz R, because I only have 2 dimensions here. The rest are just 0. So let's prove this point and just do the exact same thing, but we're just going to remove these 2 dimensions and then pack them up, and we'll get the same result, right? This is what was happening kind of under the hood because the vectors were still 0. But what he did, which was interesting, was that he decided to get the length of the vector. So the length of the vector, right, if we're at coordinate 0, 0, then the distance from 0, 0, that point, to 0, 0 is what?
0.
0, right? Because you're right there. So you don't have to go anywhere to get there. You're there. And the way this is done is, you know, a squared, let's do a to the power a to 2. So the square of a plus the square of b is equal to c squared, kind of, but we're not done yet. C 2, right? That's true. And so then we say, well, we have to do the square root of stuff, right? So when we get something like, and this is just the Pythagorean theorem. So 1 times 1 plus 1 times 1. So 1 squared plus 1. If these were 1 and 1, then what is 1 times 1 plus 1 times 1?
2.
Wow. And to get the answer of what the length of that is, we would have to know what is the square root of 2, which is like 1.414. Right? Well, who cares, right? I mean, that's true and all that, but that's not really what we need to know. What matters is that with an S norm, in the center of the S norm at 0, 0, the length is the smallest, and at the extremes of S norm, both on the X and the Y, the length is the longest, because the length is the length from the edge of this window, for instance, to the center. So obviously it's longer here than it is here. And here it's, you know, halfway. So we can take the length of this vector, let's say, this one we did right here. And let's just get rid of these other 2 things for now. So, you know, if we do this, then what's going to happen, right? That's going to mean that now we've got 1 value for the length. So we could pack up. Go ahead.
It's going to be like a radial fill from the center, right? You could do with this.
That's right. So
but can you determine length from any point, or is it just from the origin?
Just from the origin. If you want to determine length from any point, you would have to subtract the vectors.
Okay, that's not too bad, though.
No, you would just say, well, not from the origin, but from here, and you'd subtract them. And there is no nice length function for that, right? You'd have to do it yourself.
That's easy enough.
Yes. So interesting. What did I do? Okay, so let's just see what this does, right? So if we hook this up to the red, and then we hook up the output here, then we see that it's black in the center and really red as we get to the extremes. Right?
Mm-hmm.
Okay, how would I make it so that this circle in the middle is bigger? Black circle. Knowing that we can go negative numbers and it'll still be black.
Scale?
Maybe.
Can you ask that one more time?
How would I make it so that this center, and not in code terms, but here the length is 0, and here the length is like 1.414 or something like that.
So yeah, the length is getting too big too quick.
Well, the length.
Or wait, no, we need to make it bigger faster actually.
Can you just multiply the length?
Well, let's subtract the length, right? So let's subtract from some value from the length.
By the way, just to clarify here, length is doing the square root of everything, or length has just a bunch of different equations?
Length is determining, hold on just a second.
Sorry.
Let's subtract 0.2 from it. So
ignore my question. Go back to where you were doing.
This is in the wrong place. Okay. So now this is going to be bigger, right? Because length is determining how long is a vector from the center to whatever point. And there's a bunch of points here. So from every point we measure to the center, what's your length along that vector? So from the edges, the length is longer than it is from the center. But if I subtract some value from the length, then basically what's in the center goes below 0, and then these other things start being 0, right? So basically I'm just saying like, well, whatever your length is, make it shorter. So you're going to get darker, right? Because longer length is associated with brighter red.
Does length work with multiple dimensions more than like 3 dimensions?
Yes. The Pythagorean theorem works with as many dimensions as you can throw at it, which is interesting.
And it just keeps like averaging the change. But well, that's very interesting. Like conceptually, that you can apply the Pythagorean theorem to a matrix that has 20 dimensions.
Sure. I mean, that's how you measure parameter space, right? So if we had a parameter space for sound, and we said a clarinet has these features, and there's 20 of them, we would say it's a 20-dimensional space, and we would say, well, what about this clarinet sound, which also has 20-dimensional space, but these parameters are filled with these numbers? We can measure the distance between those two things, even though we can't perceive of that in a geometrical space that we understand. Okay, so this is how we made the circle bigger, right? We just subtracted the length.
Whoa! Oh my God!
So how would we? All right, so let me stop right here because I don't want to go the next step because the next thing gets weirder. We have to understand what just happened here. So what I'm doing, right, is I'm just using this S-norm thing to make my life a little better. I'm still not using the movie in any way, which is interesting, right? I'm just using this. This doesn't even need a movie, right? It just would need a bang, and I'd get the same result.
Yep, it's banging the matrix.
But I do have that movie there, and so I want to use it. So I can say in1, and there's my movie, right? There's the movie with all its values. And I could swizz out the a few values here. So how about R, G, and B, and A? We'll swizz all of these out. Why not? And say, all right, well, anything that's not the red values of this movie, let's say, but these others, we'll let those be the green and the blue. Right, and so now I've combined this idea with the other one, and I say, all right, well, I can put this red sort of fade in. Sure. But this is kind of like the whole movie's there, right? And there might be some time when you're like, well, how would I, for example, shift all of the this whole movie to the right? Like, how do I do that? Because now anytime I add something to this, it's really just changing the ARGB values. So I really need to like structurally change what's going on here. And this is where we get to this nearest thing. So there's two things, and I want to clear this up. There's nearest and nearest pix. The only difference here is that this defines the geometry of the matrix coming in as between 0 and 1. So this is normalized. And this one would do it by the cell number. So 0 to 319 and 0 to 239. So both of these want to know which cell coordinate we're talking about. It's kind of like this one would want to know based on cell, right? So if we did this and we ran the movie through it, it would give us it in the right order. You would say, all right, put the 0, 0 here, put the 1, 0 here, the 2, 0 here. This one would need norm. So instead of it going from 0 to 319, it's going to go 0 to 1. So no matter what I put in, it's always 0 to 1. So just two different ways to define it. But since we're working with 0 to 1 a lot, let's just work with this one. So what am I saying? I'm saying that if I put this movie here, and I put this movie here, it's going to look exactly the same, right? Because we're saying reposition all of the cells so that they go from 0 to 1 and 0 to 1. Well, that's exactly how they're positioned, so great. What
You
would
could
happen?
multiply by that, and so that would allow you to shift it.
Well, I think to shift, we would want to probably add to it, right? So what if we said like, well, plus 50 on the x, let's say. So remember that our norm has these 2 dimensions.
That's a lot. Shouldn't it be plus 0.5?
Oh, sorry, yeah, plus 0.5, because this is not, right, thank you. This is between 0 and 1. So that's halfway across, is there. So I'm going to swizz out this x, add this, and swizz out the y, and just keep the y normal. Not normal. Keep the y the same.
Wow, you just made this make so much more sense to me. This nearest object.
Pack up the vec here. So now I've got the x and the y. Well, you say that now, but let's make sure this works. And then we pop it in the nearest, and that's halfway through the video, right? And so now it's wrapped around. And so like our rota object, which is near and dear to me, this nearest has bound modes. And let's say clamp the stamp. Right, and so now we see that this other half, so it's kind of interesting what happened there. What if we subtracted 0.5 from all of this? Right, the other side. What if we
Sending chickens into hyperspace?
That's right. What if we use the mirror, right? And then it's going to mirror this across. Okay, so let's make sure we understand what this nearest thing is doing, because this may be really mysterious for a few of you. Like, what? So what it's doing is it's taking in this matrix, and then it says, I'm assuming if we don't put it through the nearest, that you just want the structure of this matrix, like how I draw it, to be the same as how it came in. You know, cell 0, 0 is drawn at cell 0, 0, etc. How would I make this just drawn backwards? Like, so I want this cell to start over here, and this cell to start over here, right? I just want
do 1 minus whatever x is.
Yeah, effectively scaling it in reverse.
I think we just, what would we do? Would we multiply it by, we just 1 minus, right?
Yeah.
So 1 minus whatever comes in, and then it should be flipped in reverse, and it is. If I wanted to turn it upside down, we do this, right?
Rotating it is a little tough for me.
So what you're doing with this norm object, I mean the nearest object, is you're effectively just making it
Oh.
you can use normalized coordinates on this matrix without having to conceive of like what's happening with the color or anything like that.
Right, so we're not dealing with color, right? I'm just dealing with like, okay, I'm not changing the color, just reposition the cells. So I would actually call this like, you know, reposition or something. Because otherwise we're operating on colors, right? And so the only way to operate on position is to use this nearest or one of its cousins, right?
So we can only work in one of those regards, right? We can't do like, so if we tried to do like the color and the position at the same time, it would probably freak out, or is that not true?
Let's find out. So here I'm saying like, all right, well I had this thing that let's see, where was it? Here, like we went into this vec here, right? And maybe we want to try to apply it there, and it doesn't allow us to do it. So I've noticed that. I don't really know a way around that, except maybe to make 2 different gen objects. It's not clear to me how to turn this into something that nearest wants. Input matrix to sample, it says. So this is a vector, right? And it's not a matrix. So.
But we can do color and spatial transformations in one gen object, right?
That's right. So we would just take this. Maybe. I'm not sure the answer to that, so I'm gonna duck
Hey,
out
you
of
just
it.
had to multiply, wouldn't you?
Multiply what?
Like if you took that vec that has the 4 zeros out and you multiplied that times the nearest, what's coming out of the nearest, it would change the color of that object, right?
Well, let's do. Okay, so take this vec here, multiply it by this. Yeah.
Yeah.
Huh.
There you go.
Okay. Okay. Yeah, that makes sense.
It did some other transformation though, I think. Now it's
Oh, yeah,
45
well-
degree angle.
Well, it's doing some.
So then it's changing the spatial
Yeah,
transformation.
it's like double mirrored.
Maybe you
Okay.
can do it before it goes into the
feel like
well,
I'm dri-
maybe not. I don't know. Like do
Yeah,
the multiply
yeah.
before, but I don't know. Is it once a matrix?
Well, I guess because what's coming out of the vec is like, it's going from the center, right? So that's what it looked like it did.
It won't let me do this.
Yeah.
This wants an input matrix. It's very specific. Okay, but anyway, let's not get lost in the weeds with that. And so let me clear away all of this stuff for now. Oops, I'm going to keep that. So here we've got so how would I move the image around?
You could add and subtract from X and Y.
Yeah,
to
so
the-
so instead of just this being constant, right, I could use a parameter maybe.
Yeah.
So let's say param x and param y. And so now this is going to be x and y. So now they're back to normal, and then outside of this I could change it. How would I make this image kind of move around in a circle?
Math.
Okay, what kind of math specifically?
The sine and cosine?
A sine and cosine. Yeah. So sine, cosine. And so let's say that we're going to pass in parameters between 0 and 1, and we'll just multiply them by 2 pi. And so now, now we're going to get something not quite right, because this is going from -1 to +1 if we take the sine. And ditto with this. Right, so now these are -1 to +1. Is there a way I could change what goes from -1 to +1 to simply go from 0 to 1?
Norm. Or
What about scale? So -1 to +1, 0 to 1. All right, and we'll hook these up to our okay, I got confused. So we don't want this anymore. We want this to be the x and this to be the y, or vice versa, I can't remember. Actually, it's actually backwards to do it properly, so let's do it the right way. So sine is always the y, and the cosine is the real, or the x. All right, so then is this going to work, right? It's kind of interesting. We'll see. So already we've got some weird stuff happening. And what did I call these, x and y?
Mm-hmm.
And then we'll use a clocker. And multiply by 0.001 or something. Just going to make this count a little slower. And turn it on. We'll run these values. Whoops, is that right? Yeah, here and here. And then this this goes here, and this goes here. Yeah, around in a circle.
What? Okay.
All right. Okay, interesting. And we're getting low on time. So let me show you what I wanted to show you. So right now, let's take a look at how we're doing as far as jit.fps goes. FPS GUI. And I'm going to put this here. So we're not too bad. We're like 30 frames per second. That could be based on the movie. Let's say that I want different bound modes.
I'd like to know, why does the frame rate change?
Because the computer is having a hard time. I'm going to have multiple bound modes now. And you cannot change these bound modes dynamically. So if you want to change them, you're going to have to select between a few of them. So the other bound modes are like clamp and wrap. And so now I will run this into here, and this into here, and this into here, and into here. And then I'm going to be able to choose between them with a selector. So 3 different things being able to go in. So the first one, the second one, and the third one. And then some param like bound mode. Default it to 1.
Is
And
there
now,
a reason they force you to do the parameter stuff instead of allowing you to work with numbers within Gen? Like number boxes and things?
probably. All right, so now we've got, this craziness, and my frame rate's kind of suffering a little bit, and it'll suffer more and more the more of this I do. So let's copy this all, and I'm going to close it. And now what I'm going to do is I'm going to replace this jit.gen. This is the whole point of what I wanted to get to, so pardon me if I run over. I'm going to replace it with jit.gl.pix. Okay, so that's going to be problematic because now we're in a texture, right? And if we're in a texture, that means we need to be in a world, right? So we'll make a jit.world. Displace. And now I'm going to put a video playing on this world. And I'll run this texture out to the video plane. Turn on the world. Uh-oh.
You need to paste your stuff back into jit.gl.pix.
Let me just make sure this works without this here for a second. So that looked like it was going then, didn't it? What is happening? Okay, so weird. But I do need to do that. Yes, thank you, Andrew. And
I think
so
part of it is you have like whatever the clocker is continually running into it too. I don't know if that's necessarily doing anything.
Well, this is kind of proving me wrong in many ways. Oh, there we go. It just freaked out for a little while. I don't know what happened there. All right, and then now what's happening is without me doing much work, right, it's running on the graphics card. And hopefully we'll see a frame rate improvement here. Yeah, so we're having better frame rate. And it depends on which video card you're using, but generally working on the graphics card is going to be way better. Like this showed dramatic improvement on my laptop where it was like it wouldn't even run what I'd done before. And then when I moved it over here, it started running. The point of that is that whatever you write in jit.gen to do this sort of pixel processing, so this isn't going to work with vertices, right? Because here I'm in a texture land. But anytime you're processing video, it is better to just go ahead and move to the jit.gl.pix, which is identical as far as like what's going on here. And that's what I wanted to point out today.
So that stuff just kind of, or the gl.pix just kind of does what we just did in Gen under the hood, basically.
So jit.gen does things on the central processing unit. and
Right.
jit.gl.pix does it on the graphics card. So the difference is that jit.gen is compiling down under the hood to a jitter object like jit.matrix, and jit.gl.pix is compiling down to a GL object like jit.gl.gridshape.
So jit.gen is really good to use for like calculations and stuff, but not so much like video processing because it's just so CPU intensive.
That's exactly right. You should not do video processing with jit.gen. You should really do it with gl.pix. You should do vertex processing with jit.gen. So when we're making 3D spaces, that's the best way to do it. There is a way, kind of, to do vertex processing on the GPU, but that's not really how things are designed in general. Most of it assumes that you're passing some vertex matrix into the system, and then it goes into the pipeline of the graphics processing unit.
So
Okay.
I have a question before we end. Is it beneficial for us to use the GL3 renderer instead of the GL2 renderer? Because from what I've seen on YouTube, it seems like everybody uses the GL3 and it like gets better performance out of the computer. But I don't know what objects are compatible with GL3, because I do know that some things are obsolete with GL3.
I don't think we've dealt with much in my experience, because my thing I did for last semester was in GL3, but it adds a lot of the shader stuff, and it just is not very well documented, was my experience for the new things.
I would not move to it. I've found bugs in it already that I reported. They're still working on it.
Okay, because I was wondering, you started using it like this morning, and I noticed a lot of things just did not work. Or a few things, at least.
I would not use GL3 at this point unless you have a specific reason to use it.
Okay, cool.
It'll work fine with GL2. Okay, so the things we covered today, I did record this, and the things we covered today were try to clarify how SNorm, norm, cell, and dim work specifically. And then we also covered the length thing, which is pretty cool. And I won't bother right now, but we could, for instance, get the length of all of these values. Anyway, and reposition them. And reposition this actual thing. So if you want a challenge, then how would you make it so that this nearest thing uses that length, which makes a circle, and make a circle out of this video, like concentric circles going out. You would just basically have to resample this, taking that into account. We did length, SNorm, norm, cell, dim, and then we looked into nearest, which is how we resample the positions of a matrix, right? So there's different ways to use that. So now we approach a time when we have a week of break. You have the midterm in front of you that you can do and turn in at your leisure before next Tuesday. For those of you that are participating in the ensemble thing, we will meet tomorrow in the tech lab, trying to be set up by 1:30 if possible. And that way we can just work on straight up rehearsing this piece for a short time and then tear down and be done by 2:30. And hopefully we'll get to play a little bit of music and not just explain the whole time. So if you can look at the score ahead of time, that would be good. Do you need me to print out the score ahead of time, or is it easy enough for you guys to print it out?
I'm going to print it off. I already printed it off yesterday.
Andrew, would you like it printed off, or do you want it?
Sure.
You'd like it printed off. Ryan, it's probably gone already. He's got it.
Could you print one for me, Dr. Thompson?
I can.
Cool. Thank you.
Wait, are you part of this thing on Friday, Tyler?
Is it which one is it?
This is the Holland Hobson piece. Because I don't think I had you part of it because it calls for sustaining instruments that can glissando, and I couldn't think of one you played.
See. No, that's not masking songs, is it?
No, so that'll be scheduled some other time. This is just Holland Hobson. This should be Ryan, Jarrett, Alex, myself, and Andrew.
Okay.
All right.
Cool.
Okay, I'll post this video in case you want to review it. I do recommend becoming familiar with this gen object and so forth. It's pretty powerful, and the GL.pix object becomes more and more important as we deal with texturing things and video. All right, see you guys later.
All right.
Thanks.
you.
Bye.
Let me stop the recording.